So if we look at this example we have right here, we can see that we have positive charges, we have negative charges. And we can see that this is highlighted as well with the numbers we have up here. So I'm going to give a couple pieces of advice on how we're going to solve this question. First thing I want to do is I want to use logic in order to find the direction of forces. Now, what does that mean? Well, if we look at our diagram here with B and C, we can see in this particular case they're going to be attracting because it's positive and negative charges. We can also look at the example between C and A, where they're positive charges, so therefore they're going to repel. I can figure this part out logically. I also want to ignore the sign of the charges when doing the calculations. So now that I have these true rules in mind, well, I've got to answer two parts. First thing I'm going to do is I'm going to do the calculations for my attraction right here. So this is the force between B and C, which is going to be K, Q1, Q2 over R squared. So I can look these numbers up because they're written in the question. So I'm going to go 9 times 10 to the 9. I have 2.5 times 10 to the negative 7 and 6.4 times 10 to the negative 6. Now the distance between B and C is 10 centimeters. I need to convert that squared, and when I plug that into my calculator, I get an answer of 1.44 newtons. I'm going to leave the direction out for just a moment. Let's finish our other calculation here, and let's compare C and A. So the force between C and A. Yet again, it's K, Q1, Q2 over R squared. So 9 times 10 to the 9. 4 times 10 to the negative 6, and 6.4 times 10 to the negative 6. Now, what's my distance going to be? It's going to be between A and C. So it's not 10 or 20 centimeters. It's going to be 0.3, so 30 centimeters. And when I go and plug this into my calculator, I end up with an answer of 2.56 newtons. Okay, so we're asking ourselves to figure out the net force on sphere C. So what is that going to look like? Well, I'll just draw a new free body diagram here for C. In this particular case, we know between C and A there's going to be a repulsion, which means I should be labeling this as being 2.56 newtons. We can see between C and B there's going to be attraction, so therefore this number is going to be 1.44 newtons. So therefore, if I want to figure out the forces on C, so like the net force on C, that's going to be 2.56 minus 1.44. Because you can see right here, in this section right here, I've stated that positive is going to be to the right. So when I go ahead and I work this out, I end up with an answer of 1.12 newtons to the right.